You cannot have building on light gauge. You cannot put your life on it. The problem is the fragile. It's a Pepsi can effect. How floor you can go? How many floor high you can go before it breaks? Nobody knows. Yes, there is calculation, but it's fragile. And in construction, we really don't like fragile. We want the building to tell us if it's going to break. And this, you cannot get it with the LGS. The manufacturing process of the LGS is very simple. It's very basic. It's a roll-forming machine on a coil. You can get thousands of meters per month. That's very easy. However, the hot rolled cold form require heavy equipment, well-established manufacturing facility to be able to reach to the level where you have 8 mm or 9 mm or even 12 mm thick column, which is precisely fabricated to take the load of the construction in both direction, upwards and downwards. Flexibility in design. Now, the problem with the LGS here is the fit out. Now, we have a lot of wall-bearing load in the LGS. Load-bearing wall, you cannot cut it. You cannot add something. You cannot change in the future. So you're stuck with the design which you make for the lifetime of the project. Where in our system, we are very flexible. It's just similar to the conventional. You have columns and beams. Just avoid them and do whatever you want. You want to open walls, close walls. That all can be happening any time of the project for the next 30 years. Sustainability, of course, it's much more sustainable to have a long span life for the building itself, and the transportation durability. Now, this last point is very important for all the modular companies, and they are familiar with it. We finish the module, we are happy we meet the deadline in the factory. We put it on the trailer and we say bye-bye. Next day, we come to the site and the module full of cracks that requires more than 100 man-hours to repair for just shifting it from A to Z. That's the problem. That's a great problematic for us in the modular. We must have a steel structure that can undergo the whole road humps and bumps and reach without a single crack. You must have durable structural system, and you cannot go with the light one. Our case study today is very basic. It's very simple, but yet very realistic. Here we have a client whose mindset on a container-based structure. He's happy with the structure. He likes it, and he wants to do the same. However, we start discussing with them regarding the actual modular work, which is not actually containerized, something really a little bit more advanced. So the client has started with this initial design. He needs a very simple, basic G+1 office, containerized. Now, you can see the static of this building. It looks something is ready to be shipped. Even if it's after you fix it, you can just remove it. It's very, very industrialized. You cannot really look at it as an office building for your employee. So this is before, as he proposed or as he wanted, and he need a lot of it, and he executed a lot of that, and we transfer it to this. So here, coming back to the modularization, we have added, if you see, the airlock, where I put the stairs in it. So here, it's very important, especially for the modular building, the humid, especially in this region. Humidity, the humid air or humidity, it's really destructive for us. So having an airlock in this atmosphere will secure very well healthy environment for the building itself, rather than the people living and working inside. And this is the division of the modular, which is quite interesting, as we have divided the module as full dry or wet and dry. So the full dry is very basic type. It's a dry. I don't have pipes. I don't have water. I don't have HVAC. I have the duct, but not the machine. And the wet dry, where we have put all the bathrooms, the AC unit, FC unit, everything has been done in this 3 modules, which you can see it, which is 2 types. So in this way, I have manufactured large part of the building very fast. We're concentrated on the heavy, detailed modules. And this is what we ended up with. So you can look at a building that is a little bit more statically approved. It looks like a building. Yes, it could be better, but looking at the budget, this has been done in less than 700,000 dirham, G+4, 500 square meters. It's quite nice, actually, if you ask me. And you can see the modules being lifted up. Again, I'm getting upward gravity. It's quite challenging for the module itself. And from inside, you get yourself quite nice offices. And this can last for 30 years. It has been done in 45 days. It's quite nice. So what I want to shed the light or focus in here that it's quite important to look at the steel structure itself. It's a core element of the module, and it's most important to be done properly. We cannot rely on the tolerances we have right now. The contracting or main contracting aspect of tolerance should be drastically changed if you really want to go high. Yes, this is G+1 now, but you can make it G+6 and G+8, but you cannot make it with the tolerances that is approved now. You must go for very, very low margin of tolerances. Thank you very much.
Thank you, Bash. Very, very insightful presentation. I still have one more presentation for you for the day. Let me welcome Mr. Robbie Nelson, the modular manager of BK Gulf. He also will brief us about the modular system they have. Mr. Robbie, you have the floor.
Good afternoon, everybody. It's been a great conference so far. We've heard a lot of good presentations. I hope you have the appetite for just one more. So, as I said, my name's Robbie Nelson. I'm the manager of BK Modular, and I have over 20 years experience in the construction industry. This picture is in fact me, just a younger version. So today we're going to talk to you about using modular solutions specifically for residential and hospitality developments. But first, brief introduction to BK Modular as a company. BK Modular is a fully owned subsidiary of BK Gulf, and we are part of the Duckhole Construction Group, who's been working in the region now for over 45 years. However, our modular business was first established in 2008 as a specialist MEP manufacturer, but since then we've grown in size and capability. So now we have our manufacturing hub in Jebel Ali, which is just over 45,000 square meters. And we have satellite workshops in both Saudi Arabia and Qatar. Our specialist manufacturing capabilities range from modular buildings, both temporary and permanent, to industrial skids, DNV and container conversion, as well as MEP modules. So when we're talking about using modular construction specifically for hospitality and residential, we're looking at the alignment of the objectives. The benefits of modular construction have been talking about a lot today. They're wide-ranging, but we've picked what we feel to be the three specific objectives and benefits when using modular construction for hospitality and residential. So these are to minimize the environmental impact, maintain the brand and quality, which is especially important to residential developers and hospitality operators, and then also reducing the time to market so the assets can be realized as early as possible. So first, we'll talk a little bit about the environmental impact. So we've been doing a lot of investigation and research on embodied carbon in buildings. So for most of you, you'll be familiar with this term, embodied carbon. So this is the carbon that's consumed by a building throughout its full life. So that comes in three main areas, which is the upfront carbon, ranging from the manufacturing of the materials that go in the building, the construction of the building itself, the end of life, so when the building comes down, being refurbished or being demolished, and then obviously we have the operational carbon, when that building's being used, inhabited, it's using carbon through electricity and other utilities. So to control that embodied carbon, we look at the hierarchy of control in order to reduce the consumed carbon in each building. So from here, we've tried to identify where the particular responsibilities sit with the developer or owner, and then where the contractor or the manufacturer can have the most amount of impact or added value into reducing that carbon. So we start off with building nothing, reuse or repurpose buildings. In the event that that can't be done, we move into building less. So most of the residential developers, those that are in the room with us, this is managed by not creating surplus demand in the market and only building what is required to satisfy the demand. Then we move into the element where the manufacturer and contractor can have the most impact. So we look at building clever. So one of the main clever aspects of modular construction, especially volumetric, is that that building can potentially be reused and refurbished, either in position, or it can be dismantled, taken back to a workshop, refurbished, and then redeployed in a new location. We look at building efficient, so we maximize the use of materials. So this is planning from early engagement to make sure we're getting the maximum use of our materials, reducing the waste of that material, and in some case even having unique products manufactured to a size or a format that will suit your manufacturing. And then finally, reducing waste. So by manufacturing an off-site environment, we're able to control our materials to a much higher level than you would traditionally on site, and therefore reducing waste. So this is a study that came out of a university in South Korea, where they compared a like-for-like building, construction between traditional and modular, and the embodied carbon within the footprint of that building. So you can see here on the right-hand side, we have the traditional building where the majority of the embodied carbon is coming from the RC structure, is using 440 kilograms of CO2 per meter squared, compared to the modular structure, which is only using 280. So that's a 36% reduction in the embodied carbon within that building, which is a huge saving. So moving on to the maintaining the brand quality. As I said, for residential and hospitality owners and operators, their brand is particularly important to them. We're in the Hilton Hotel today. When you're in a Hilton Hotel, they need to know it. You need to know when you go into that room that you can maintain your brand. So looking at a module as a product rather than a project allows us to have repeatable preloaded designs that are scalable with no need of redesign and reapproval. So that helps obviously with cost efficiency, predictable outcomes, and you're maintaining that all-important brand quality and recognizable. So another fact we've talked about today is the reduced time to market we have. So having an asset ready earlier means revenues can be realized earlier, and we also have a product then that can be rolled out and produced en masse. So mass customization, another lesson we've learned from the automobile industry, which has been referenced a lot today, is that combining the efficiencies of mass production with the ability to customize individual products. So similarly to when you're buying a car, you buy one standard model and then you have add-ons from there. That's what we look to bring to the modular construction system. So we have standardized chassis, standardized cages that can be repeated, but the finishes, the look and feel have elements of customization that the customer needs. So this is an example, as we said. So the structural cage, similar to the chassis of a car, becomes the same for every product. The room arrangements, we try and minimize the amount of room types we have to gain the most amount of repeatability, and these ratios are what are considered to be the optimum ratios for a type of module for mass production, mass customization. So for our system itself, we use a hot rolled steel volumetric structure. So this is designed to suit the application, whether it be ground floor only, G+1, G+3. So we have structural columns and beams to make that block for the module. The flooring itself, we use a system called Lewis decking, which is a GI sheet system and concrete infill. We have acoustic strips and a fire rating board with that allows us to achieve the acoustics and the fire rating of the floor. And then we have a drywall infill system again, which allows us to select the right product for the right application for external vapor barriers, U values, then move into internal partitions for wet and dry areas to make sure we have the best system. Obviously, each module comes with its MEP services, AC ventilation, light and power, ELV and fire life safety systems. And then, as we said, the final interior finishes and joinery, which tend to be the most customizable element in the module. So when we look to vertically integrate our modules, a hybrid construction system is what we feel to be the most practical and the most efficient way of implementing that, which we've seen in other presentations today, so it's good to see we're thinking along similar lines. So in this example, we have a traditional substructure, traditional ground floor slab, which houses the MEP and utility areas. We have a first floor transfer slab for the structural loads coming for the module, and then we have cast in situ cores to give us the lateral stability. So when that wet trade work's done on site, we have the steel volumetric modules to form the infill of that structure, which come with a self-locating, self-connecting mechanism. So obviously the benefit of these modules are that when they've arrived on site, when they've been connected and erected, all the interiors are already completed, almost in a move-in condition. So each of these apartments are ready to go. Once you have the connections done on site, then you've only got the roof waterproofing, the exterior connections to do, and then your building, your product is ready. So this is just a little extract from the structural design for that project. So as you can see here, we have the RC cores cast in situ to provide us the lateral stability, and we have the volumetric steel infill. So some of the key points you can take away from this is the displacement from the roof is actually much less than a traditional building. And we also obviously have reduced building weight by up to 42%, which fits well again with our carbon footprint to build less. So moving on from what we see being the physical work, physical fabrication of the modules, technology is a ever-growing asset that can support us. So we're using now with one of our partners from the UK is an AI software that allows So just to finish up, we've picked one example project. So this was a project we did actually a couple of So thank you very much for your time. I hope you take something from that. Thank you.
Thanks a lot, Robbie. It was a great presentation and a lot of new ideas even to start scratching our heads. I believe our presence today with such crowd, we can see even until the last session of the day, even though it's a Friday, even though it's after a very tiring week, proven how much this topic is very important to our local market. Everything has a start, it must has an end, but this is the end only of just of this episode of our journey, but it's not the end of our passion towards innovation and knowledge sharing. We believe this is our commitment, it's our duty for the society which hosting us. I believe that we did our best in order to deliver to you what we thought is useful. I hope that you find that we delivered what we promised. Now, at the end, there is a word of thank you, which is due. First, I would like to thank all the teams of the 3 co-hosts from our company, China State Construction, from ICC, and from Construction Week. Really, the team worked very hard to bring this nice and heavy meal to you. I would like also to thank our co-sponsors, the ACI, the CIOB, as well as also all our exhibitors who are present here with us. They never save any efforts to come and share their knowledge with you. If you miss to visit any of their booths, they are still outside. Take the opportunity after closing out this session to reach them out, exchange the knowledge with them, get their contact, and let's be all in touch, pushing this market towards the direction where it should reach. Now, thank you for all of you to stay in touch with us until the last of the event. Of course, your opinion is very, very important to us, and we are improving this event year after year based on the feedback we are collecting from you. This QR code is the same one you can find at the end of the book. Please spare a couple of minutes to give us your feedback. Thank you very much. Have a nice weekend and see you next year.